Yes, in this third video, like I promised, I'll be talking about polynomial division, which is an extension of the second video, the last video I made on um, operations on polynomials, where we looked at addition, subtraction, and multiplication of different types. So here, I think polynomial division it requires a separate video where I can actually go in depth and explain how some of these things go. So let's come along as I talk about polynomial division. Of course, we know normally, um, before I even go into polynomial division, right? Let me talk about okay, yeah, let's take this first part and then I can talk about what I wanted to talk about. Talking about regular numbers. I'm torn between the two. Okay, let's just go ahead. Normally, if I have 8 divided by 2, that's simply 4. And in this case now, we say 8 is the divisor, is the I think it's the dividend, yeah. Is it the dividend now? And 2 is the divisor. I think I remember that. And then 4 is said to be the quotient. Okay. 4 is the quotient. So I think that's something we really need to pay attention to. In another form, if we have 9 divided by 4, we get one whole number. Or no, not one. We get 4 goes in 9 twice, and then we have a remainder of 1 out of 4. So in this case now, again, 9 is the dividend. That's what we are sharing. And then 4 is the divisor. That is what we are sharing by. Okay. And then 2 is the quotient. 2 is the quotient. And here we say 1 is the remainder. Okay. 1 here is the remainder. So knowing this kind of idea is going to be pretty helpful for us as we talk about polynomial division. So let's come there and talk about it. So division algorithm for polynomials, I think I made this particular slide. I talked about it in the previous video as an introduction to this new video. So for polynomials f of x, if we have polynomials f of x and d of x, which is not equal to 0, so definitely anything you're dividing by must not be equal to 0. Because if you divide by 0, it is undefined. So there exist unique polynomials qx and q of x and r of x, such that f of x is equal to d of x multiplied by q of x plus r of x, right? So where either r of x is equal to 0, this r of x can be 0, just like in this first case now. So here there's no remainder. There's no remainder. That's why r of x is 0. And here there's a remainder. So r of x is like what we can see as that 1, right? So r of x is 0, or the degree of r of x is less than the degree of d of x. So in this case now we say that f of x is the dividend, d of x is the divisor, you know. Okay, like what I showed here. So d of x, this is like my f of x now. The dividend, okay? And then the divisor is the d of x, what we are dividing by. And then we have quotient and all that. Q of x is the quotient. So 2 now is what I can see as my quotient. That's Q of x. And the remainder 1 is R of x. So when R of x is 0, when there's no remainder, like in this case, we say R of x here is equal to 0. But I mean, these are not functions, these are just numbers. But I just needed to explain using this idea so that by the time we get into it, you'll not get lost. Okay. So we have dividend, we have divisor, we have quotient and remainder. Don't forget the divisor has got it can be 0. It should not be equal to 0. It can be less than 0, greater than 0, but not 0, right? So we find q of x and r of x using, so what exactly we're looking for is we find q of x, which is the quotient, and r of x, which is the remainder, using two methods. Basically, we have the polynomial long division, which is the general one, and we have the synthetic division, which is the special case when dividing by x minus c. So the general one simply tells you that whether you're dividing by x minus c or not, you can always use the long division method. So I'm going to talk about those two methods. I know they can be quite tricky. That's why I'm particularly interested in talking about it. Okay. So imagine, let's talking about the long division method. So you have 2x cubed plus 3x squared minus 5x plus 6, and you want to divide by x minus 2. Okay, I mean, I'm just going to run through what we have here. I know it may not be quite clear, but then I'll go to the worksheet and actually run this out. So see what's happening here. So you take this 2x cubed now, you divide it by x. Okay, 2x cubed divided by x, you get 2x squared, right? So that's the quotient so far is 2x squared. Then you multiply back. That means that this x minus 2 now you multiply by 2x squared. And of course, in the previous video, we already saw how to do multiplication. So 2x squared times x minus 2, of course, 2x squared times x, that's 2x cubed. 2x squared times minus 2, that's minus 4x squared. We have that. So next thing is you're going to subtract. So then you have this whole expression. You subtract 2x cubed minus 4x squared from it, and you get 7x squared minus 5x plus 6, right? So what's the next thing you do? Then this 7x squared now, you divide by this x. So you have 7x squared minus x, and that is 7x. So the quotient so far is now 2x squared plus 7x, right? So the quotient so far is 2x squared plus 7x. That means the 2x squared you had here plus the 7x you now have here, okay? So you now multiply that by x minus 2. I know, don't worry, if you don't get it, don't worry. I'm going to do it in a more graphic way that you can actually flow with. So, but just don't worry. So you have 2x squared plus 7x multiplied by x minus 2. So you multiply this now, you get 7x squared minus 14x. So the next thing you want to do now is to now subtract this 7x squared minus 14x from 7x squared minus 5x plus 6. So you get 9x plus 6. Then you divide by the leading term again. So the leading term is 9x. Divide by x, you get 9. So the coefficient so far, you have the 2x squared plus 7x you have here. Now you add 9 to it. Then this 9, now you multiply by x minus 2. You get 9x minus 18. Then you now have 9x plus 6 minus 9x minus 18. That's 9x minus 9x cancelled. 6 minus 18, that's 6 plus 18, which is 24. Okay, so the remainder now is 24 because there's no x again. So once you don't get 0 here, so it means that this is the remainder. So this is 24, and the degree is 0. Of course, it's constant, and it is less than 1, so we can stop here. So we have 2x cubed plus 3x squared minus 5x plus 6 over x minus 2 equals what we got, 2x squared plus 7x plus 9 plus 24. So this is like the dividend. The divisor is x minus 2. The quotient is 2x squared plus 7x plus 9. And the remainder is 24. Of course, out of all over the divisor. And then we get this expression. So 2x cubed plus 3x squared minus 5x plus 6 equals x minus 2 into 2x squared plus 7x plus 9 plus 24. Now, I know you probably did not get that. Not a problem. So now follow me. You have to get it now. So we want to divide 2x cubed plus 3x squared minus 5x plus 6 by x minus 2. Okay, that's what we have. So like always, okay, I was gonna change the marker color. Okay, I think we're good. Can I drag this down? Okay, let me just pick the stuff and go. All right. So this is what you're gonna do. You have this now. You have 2x cubed plus 3x squared minus 5x plus 6. Now, one very important thing you want to do here is be sure that if there's any degree that is missing, you replace it by 0 something. Maybe I'm going to do another example that explains this idea of that 0 thing. Or let me see if the next example, the next example does not have this. Okay, so I'm going to do this and do another example that involves that 0 thing so you can really understand what I'm talking about. So now you have 2x cubed plus 3x squared minus 5x plus 6. You want to divide by x minus 2. So it's the same thing I just explained over there, but it's not this graphic. Okay, so what we're going to do here is now we say 2x cubed divided by x, right? This x now goes into x cubed. That was exactly what we did over there. So x cancels one of x here. So you have 2x squared, okay? You have 2x squared. So with this 2x squared now, so this 2x squared, you now multiply it by each term here. So 2x squared multiplied by x, that is 2x cubed. Then 2x squared multiplied by minus 2x, that is minus 4x squared. Does that make sense? So x goes into x cubed, you have 2x squared. So 2x squared times x, 2x cubed. 2x squared times minus 2, that's minus 4x squared. So with this now you subtract. So you subtract like this. So 2x cubed minus 2x cubed, 0. Okay, or you don't have to write anything. 3x squared minus 4x squared. That's 3x squared plus 4x squared. That's, or if you like, you can put the minus in between here. Maybe that helps. So this automatically just cancels out, right? Then 3x squared minus 4x squared, that is 7x squared. Okay? Now that you have this 7x squared, if you remember, we also saw 7x squared the other time. So with this 7x squared, now the next thing you're going to do is this minus 5x, you bring it down here, okay? Bring minus 5x down. So what's the next thing you're going to do? So this x again, okay, I think that's one procedure gone. So maybe I should change the marker color, the color to emphasize that we are going for the next level now. So this x now goes in 7x squared. How many times? So x cancels x, you have 7x, and that's positive, right? So we have plus 7x. Okay. So what's the next thing you do? 7x times x, that's 7x squared. Okay. Then 7x times minus 2, that's minus 14x. It's exactly what we did over there. Now we want to subtract again. So subtract, subtract. So you have 7x squared minus 7x squared. That will automatically cancel out. But here now you have minus 5x minus 14x. That's minus 5 plus 14. That is 9x. Okay? Now that you have 9x, then you bring down the last value. That's 6. Okay? Now that is done. So I'm going to change the marker again. So you get the gist. So now we go the next level. Okay, maybe I can shrink this. Oh, okay, yeah, I can shrink this a little bit. So x now goes in 9x, 9 times, right? So x and 9x, that's 9. That's plus 9, positive 9. So now 9 times x, that's 9x. Then 9 times minus 2, that's minus 18. Okay? So again, we subtract. So when we subtract, 9x minus 9x, that's also cancelled. Then 6 minus 18, that's 6 plus 18, that's 24. Okay? That's exactly what we did over there. So we can then come and say, therefore, um, 2x cubed plus 3x squared minus 5x plus 6 all over x minus 2 is the same thing as the whole number we get. This is the whole part now. This is like our quotient now. This is the quotient. Don't forget. This is the dividend. Okay. This is the dividend. This is the divisor. Or I think some people call it divisor. I'm not sure. I didn't check how to pronounce that. And this is the remainder. Okay. So the 4 parts. Okay. So now, this is equal to the quotient 2x squared plus 7x plus 9. 2x squared plus 7x plus 9. So you have 2x squared plus 7x plus 9. All right. Then plus the remainder, that's 24, all over the divisor or divisor. Okay. So which you can then still express, if you like, you can still express that and say that you can still say this is the same thing as, like, you multiply through by x minus 2 now. This is the same thing as 2x cubed plus 3x squared minus 5x plus 6 equals 2. Okay, you can say this is now x minus 2, the divisor, multiplied by the quotient 2x squared plus 7x plus 9. Then x minus 2 cancels out there. So you just have 24 as your remainder right here. So from that expression, from that initial expression, what we have is that this guy now is f of x. Okay, this guy is d of x, which must not be 0. And this is your, I think, was that q of x? I think this was q of x. And then this other one is r of x, the remainder. Okay. So this is the dividend, this is the divisor, this is the quotient, and this is the remainder, like that. So that's how that goes. Okay, now that we have done that, we can go back to where we are coming from. So that's for long division. Oh, yeah, I promised I was going to do something to show you that if a degree is missing, you cannot overlook it. Okay, if a degree is missing. So imagine you have to divide x, say you want to divide x raised to the power 4 minus 1. All right, divided by x, say, I don't know, what should I do? Let me just say x plus 2. Okay, if you have to do this, what do? Again, you come here and you have now every degree that is missing, you have to bring it back. So you have x raised to power 4. Degree 3 should be next. So you have plus 0x raised to power 3. Degree 2 should be next. You have 0x raised to power 2. Degree 1 should be next. You have 0x raised to power 1. Okay. And then the constant is -1. So you can leave that. So every missing degree needs to come back. If not, you're going to get confused. Okay. Then you can have x plus 2. So you have to set it up this way first for easy division. So then you can go ahead and start working, because if these things are missing, you're going to have issues later. This is 1x raised to power 0. So that's constant. So now you say again, x in x raised to power 4, because that'll be x raised to power 3, right? And then you have x raised to power 3 times x, that's x raised to power 4. X raised to power 3 times 2, that is plus 2x raised to power 3. So you see why this has to be here. So you can compare the two together. So now you can subtract. So x raised to power 4 cancels x raised to power 4. So you have 0 minus 2x raised to power 3. That's minus 2x raised to power 3. So that 0 helps you as a placeholder. So then now you can bring down plus 0x squared. So first step is done. So for the next step, what do? You have, so now x into minus 2x cubed. That'll be x cancels x. So you have minus 2x squared. All right. So minus 2x squared times x again is minus 2x cubed. Then minus 2x squared plus 2. That's minus 4x squared. Does that make sense? Minus 2x squared times x minus 2x cubed minus 2x squared times 2. That's minus 4x squared. So we have this. We can subtract now. So minus 2x cubed minus 2x cubed, that's minus 2x cubed plus minus 2x cubed. That cancels out. Then we have 0 minus 4x squared, that is 4x squared. And then this is 0x. So we have 0x like this. We'll bring that down. And then we can go for another level. So now x again goes in 4x squared. X cancels x, right? That's plus 4x. Okay. So you now say 4x times x, that's 4x squared. Then 4x times 2, that is plus 8x, right? 4x times x, that's 4x squared. 4x times 2, that's 8x. So we subtract like that. 4x squared times 4x squared, this cancels out. Then 0 minus 8x, that's minus 8x. Don't forget the last number remaining is -1. So we bring down that -1. And then we go for the last round. So for this last one now, x goes in minus 8x. That will be minus 8 times, right? So minus 8 times x, that's minus 8x. Then minus 8 plus minus 8 times x is minus 8x. Minus 8 times 2, that's minus 16. And then we subtract. So when we subtract the minus 8x minus 8x, that's minus 8x plus 8x, that's 0. Then minus 1 minus 16, that's -1 plus 16. And that means the remainder is 15. Okay? So now that the remainder is 15, now so therefore, so we can say therefore x raised to power 4 minus 1 all over x minus x plus 2, right? X plus 2 is equal to the dividend x cubed minus 2x squared, x cubed minus 2x squared, all right? X cubed minus 2x squared plus 4x plus 8, plus 4x minus 8, all right? Plus the remainder 15 all over x plus 2, I think. Yep, all over that. Then we can multiply through by x plus 2. So we have x raised to power 4 minus 1 is equal to x plus 2 into x cubed minus 2x squared plus 4x minus 8 plus 15, because x plus 2 cancels out. So in all, now we see that this is the dividend. This is the dividend, what we are dividing. And then this is the divisor, what we are dividing by, the divisor. Then we have the quotient, the result we get, at least the whole number we get. And then this is the remainder, what is left over. Of course, there are cases where you don't have, maybe I should try a case where there's no remainder. I think that's also important. I know for sure that x raised to power 2 minus 4 all over x plus 2 will have no remainder. So again, in that case, I'll just go straight. I have x squared. There's no x because you have to have every order. So there's power 2, there should be power 1. We have power 0 already. So that's plus 0x minus 4, then x plus 2. Okay. So x goes in x just 1. So we have x times. So x goes in x squared 1. It cancels out, we have x. X times x, that's x squared. X times 2, that's plus 2x. Then we subtract. When we subtract like that, this cancels out. So 0 minus 2x, we have minus 2x. And then you can bring down minus 4. Then x goes in minus 2, that's minus 2. 2 times minus 2 times 2 times x, rather, that's minus 2x. Minus 2 times plus 4, that's minus 4. Then we subtract. When we subtract here, see minus 2x times minus 2x minus 2x, that's minus 2x plus 2x, that is 0. Then minus 4 plus minus 4, that's minus 4 plus 4, that is also 0. So there's no remainder here. So we just said, therefore, x squared minus 4 all over x plus 2 is simply equal to x minus 2. Okay, it's x minus 2, and there's no remainder. Okay, x minus 2, there's no remainder. So it means that x plus 2 goes perfectly in x minus 4, right? So we now say, therefore, that's x squared minus 4 equals x plus 2 into x minus 2. So in this case now, this is our dividend. This is dividend. This is divisor. And this is quotient. Okay? This is the quotient, like that. So no remainder in this case. So we have cases like that. Okay, so that's about the long division thing. I hope by now, with these 3 examples, I believe you have really got the point. Okay, so let's go ahead and talk about synthetic division, which is like a kind of shortcut to handle this issue. So for synthetic division, now it is a shortcut for dividing by a linear factor of the form x minus c. So if you have something of the form x minus c, it's sweet. So requirement, divisor must be x minus c or be written in that form. So whatever you have, you can rewrite it in x minus c form. So the dividend is written in standard form with all powers present. So just like what I showed you that time, all powers must be present. So any power that is not present, you use 0 coefficient for missing powers. So to divide f of x by x minus c, the first thing is you want to write c on the left, right? So that's interesting. C on the left, right? So write the coefficients of f of x in order. We've said that. Bring down the first coefficient, okay? Multiply c by the number just written below. Then put the result in the next column. Add down the column. I know this may not be clear, but don't worry. By the time I take the example, you'll understand. Then repeat, multiply, add until the end. Then the final row gives quotient coefficients, all but the last number, and the remainder will be the last number. Okay, so let's try it out and you understand what exactly you're doing. So we are solving the same problem that we solved before using the synthetic method as an example. I mean, using the synthetic method, that is. So here we want to divide 2x cubed plus 3x squared minus 5x plus 6 divided by x minus 2. So what happens? Using synthetic division, we have 2, 3 minus 5, 6. Okay, how did I jump there? So here now, we are dividing by x minus 2. So x minus 2 equals 0 gives x equals 2. So c is equal to 2. And since c is equal to 2, we have the coefficient of 2x cubed, 3x squared minus 5x plus 6 to be 2, 3 minus 5 and 6, like this. All right. So for the synthetic process, now see, follow. So bring down the first coefficient. The first coefficient is 2. So this 2 right here. So bring down this 2. So you have this 2 right here. So you have, so bring down the first coefficient. This is the first coefficient. This is 2 here. Then you multiply that 2 by the 2 that this c is. So multiply by 2, we have 2 times 2 is 4. Then the next thing is you now add this 4 to the next coefficient. So add to the next coefficient. So you have the next 3 now. That's 3 plus this 4, and you get 7. Okay. Then next, you multiply this 7 by 2 again. So the 2 up here. So you have 2 times 7, and that is equal to 14. Okay. Now this 14, now you add the next coefficient, so it has minus 5 plus 14, which is 9. Again, you multiply the c now, that 2, we multiply it. So 2 times 9, that's 18. So then this 18, you add to the last coefficient, that's 6 plus 18, that's 24. So now you have the final bottom row will now be such that you have So you have 2, you have 7, you have 9, and you have 24. So 2, 7, 9, and 24. After each step of addition, so the first coefficient, then after the next one, the addition you have, and then the next addition, and then the last addition. So the final bottom row is now 2, 7, 9, and 24. So these are the quotient coefficients now. 2, 7, 9 are the quotient coefficients. So it means the quotient will be 2x squared plus 7x plus 9. Then 24 is the remainder. And then you can write it in that normal form. Okay. Okay. I wrote this. This shouldn't be polynomial division. It should be practice questions. I was wondering why I have that's coming up again. But these are practice questions. Okay. Of course, don't be bothered. I'm going to go to the worksheet and explain and really do this clearly so you can follow the drift better. Okay, so I come here again. In fact, I'm going to use the method for all these three I did previously. So for the first one now, we have, okay, maybe I should just, okay, no, I can do it separately. Changing the marker, first of all, let me change to this. Okay, so now we have this. So we have to use the synthetic method to do 2x cubed plus 3x squared minus 5x plus 6. Okay, so that divided by x minus 2. So it is in that form, x minus c, right? So, but if it is not x minus c form, then we are going to have an issue. I think this last example may not work for this last example based on what I see, because I think it's strictly, except you just want to try that out. But maybe I can just do it for this and then you can try, since the general method works for everything, so you don't have to stress. So now what we have done here is this for the synthetic method. So um, since x minus 2 is what we have, so it's similar to x minus c. Okay, so we have we can say x minus 2 equals 0, which implies that x is equal to 2. So our c is equal to 2. That's the key thing here. So that's the condition for this particular method. So c is equal to 2. Now, since that is established, so what we are going to do is we talk about the coefficient. So the coefficients of the dividend, the coefficients of the dividend, 2x cubed plus 3x squared minus 5x plus 6 are, okay, you have 2, 3, minus 5, and 6. So these are the coefficients, right? So then we can now go ahead for the synthetic process. So we go for the synthetic process. Okay. I'm trying to look for a very sweet way of doing this so that it can be quite, I know there should be a way I can do it in tabular form that will drive the point home as easily as possible. So we have 2, 3, minus 5, 6. So let me just go gradually. So this is the first coefficient right here. So from this first coefficient now, so what we are going to do is we are going to, this first coefficient, we are going to multiply it by 2. Okay, multiply by that 2. This 2 now is c. Okay, we multiply by c. So we multiply by c, which is equal to 2. So this is c. This is our c, which is 2 right here. So 2 times 2 now is equal to 4. Okay, so this 2 times 2 is 4. So having got that 4, then we can now add this 4 now to the next coefficient. Okay, I think I'm getting the hang of it. So we add to this next coefficient, right? Which is going to give us 7. Okay, so don't forget, you are going to take note of this first coefficient you dropped, and then this, then the next thing here we get, when you add these two now, you get 7. So you also have to pay attention to this 7. Okay, so this 7 you have got now, then you multiply by 2 again. So you multiply this 7 by 2. That's 2, which is C now. So this is C, which is equal to 2 again. Okay? So multiply 7 by 2 and you get 14. Okay? So now that you've got the 14, what do you do again? You add it, you add the next coefficient to it, that minus 5. So you add it to that 14. So so this is now minus 5. So minus 5. Okay? So take note, this minus 5 now, after you add something that 5 to it, you're going to get 9 here. So take note of this 9. So after you drop the first one, every time you add the next coefficient, you pay attention to that number. So this is now 9. So again, what you're going to do with this 9 now, you multiply by 2. You multiply by that 2 again, which is our C. So you multiply this by 2. That is the C now. C, which is equal to 2. Whatever 2 is, you multiply. So now you have this to be 18. So with this 18 now, then you add the last coefficient to this 18. Okay. The last coefficient you add to this 18. Okay, not quite there yet. So that last coefficient is 6. Okay. So you have plus 6. So you have plus 6. And then when you add all of that, you get 24. So again, you pay attention to this last 20, to this 24. And since there's no coefficient remaining again, then we can as well just stop it here. And then, so we can then list out those things you have. So the first coefficient you dropped, after you multiply and added something to it, the next one like that, those are the coefficients of the divisor. So we can now say that the final bottom row include those numbers now: 2, 7, 9, 24. 2, 7, 9, and 24. So these first three are now the coefficients. So these are the coefficients of the quotient. Okay, and this is your remainder. Okay, so we can say, so the quotient is, so since the coefficient has 2, 7, and 9, so it's more like 2. Okay, we have 2, 7, 9. None is negative, so this is x raised to power 0 plus x raised to power 1 plus x raised to power 2. So the quotient is simply 2x squared plus 7x plus 9, basically. And then we have the remainder to be 24. So we can now say, therefore, 2x cubed plus 3x squared minus 5x plus 6, okay, plus 6 all over x minus 2 is equal to 2x squared plus 7x plus 9 plus 24 all over x minus 2. And when we multiply through, then we can get, so this implies that 2x cubed plus 3x squared minus 5x plus 6, okay, is equal to x minus 2 into 2x squared plus 7x plus 9, okay, plus 24 all over x. I mean, that does it plus 24 because we're multiplying through by x minus 2 plus 24. Again, don't forget, this is the dividend. Okay, let me change the marker here to emphasize that. So this is the dividend. This is the divisor or divisor. This is the quotient. This is the quotient. And this is the remainder. Okay. Should I just take one more example? Let me see if I should take yeah, let me just try another example. As far as if you have it in the form x minus c, or is there one I did before that is in that kind of format? Okay, yeah, this first one. Okay, this one doesn't look quite like that. Okay, let me just fabricate one and then work with it. So let me do x raised to power 4. Let me do x raised to power 4 minus 1 all over, say, x raised to power 4 minus 1 divided by, let me go for x minus 7, okay? X minus 7. So we can say that x minus 7 is similar to x minus c, okay? That means that c is equal to 7. So our c here is equal to 7. And then the next thing is we go for the coefficients. We go for the coefficients of x raised to power 4 minus 1. So pay attention. Yeah, I think this is even instructive. So the coefficients of the dividend, are, we have x raised to power 4, right? So that's 1 for x raised to power 4. For x raised to power 3, there's nothing, that's 0. For x raised to power 2, there's nothing, that's 0. For x raised to power 1, there's nothing, that's 0. And then for constant, we have minus 1. You get that? So you have to fill up the space. So x raised to power 4, so this is for x raised to power 4, x raised to power 3, x raised to power 2, x raised to power 1, and this is x raised to power 0 already. So now we have the coefficients, and then we have our c. So these are the two things we basically need to proceed. We have this now. Thankful. Okay. Yeah, we can verify this later as we move on. Okay, so now we have all this in place. So again, try. This is okay. Well, at least we know. Well, you can just hold this in your brain. We have 1, 0, 0, 0 minus 1. So then we can go for the synthetic process. Synthetic process now. So the reason why we're using the synthetic process is because at least we have x minus 7 that's in the form x minus c now. So what do? First thing, bring down. So we have first coefficient. First coefficient is 1. So we have first coefficient, that is 1. That is 1. So you want to pay attention to that. Okay. So that's 1 now. What do you do with it? You multiply it by 7. Okay. Multiply by 7. Okay. Multiply that by 7. And that 7, that gives you, that's simply 7, right? That's 7. And what do you do with this 7 now? This 7, you then add it to 0, okay? Which is the next coefficient. All right? Or okay, let me just do it in a straight form. So 1 times 7 is 7. So you now add it to the next coefficient. And once you add it, you have 7 again. Okay? You have 7. So this new 7 you have now is now your second, is now your new is now your second coefficient. So now this is second coefficient. Okay, second coefficient for your quotient. So you can box that again. So now this new coefficient you have now, then you multiply it again by 7. So multiply it by 7 and you get 49. So and once you get this 49, then you again add it to, then the next thing you want to do is, what's the next coefficient now? You have 1, 0, 0, minus 1. 3 zeros, right? So we have taken care of the first one is done. So we've added it to 0. Then we multiplied, and then we add to the next 0. So this is second 0, so we have 49. So, and once you add again, this is another coefficient you want to pay attention to. Okay, this is another coefficient. So, and once you have this other coefficient, what do? You multiply it by, 7. Wow, this is getting serious. Multiply by 7. Okay, and that is 343 straight up. So this is like, so you add, okay, yeah. So multiply by 7. After multiplying by 7, you add the third 0. So we have 1 0 here. This is second 0. And you add the third 0, which is the third coefficient. That is 343. Okay. So now once you add again, you want to pay attention to this other coefficient. That's 343. Okay. So that is here. This is third coefficient. Third coefficient. But third coefficient. You know, because that thing is power 4, we are going to have it is power 4, right? We should have this. The other one was power 3, so we had three coefficients. So now we have third coefficient. Yeah, third coefficient. Then this is now fourth coefficient. And then we are going to have a fifth one, which is going to be the remainder. So now this 343, this one we got now, and we now add it to, we multiply by 7 again. Wow, this is serious. We multiply by 7. So 7 times 3, 21. I hope I'm doing the right thing. 7 times 3 is 21. 7 times 4 is 28. That's 29. That's 21. That's 2391. So this would be like now be like the remainder. So this should be our remainder now. I'm not. I hope. Okay, then no, this cannot be the remainder. So after multiplying, right, we have to still add the last coefficient now is -1. So we have -1, and that would be 2390. That's 2390. And then we have to pay attention to this one. So this is the remainder now. Remainder. Okay. So we have those coefficients. That is 1749. 1749, 343. One, okay. Last row now is, okay, I guess I want to change the marker. Last row is 1749, 343, and then we now have 2390. 2390. So this is for the quotient. I mean, this is for the quotient exactly. So that's 343 x raised to power 0, x raised to power 1, x raised to power 2, x raised to power 3. We have x raised to power 3 plus 7x squared plus 49x plus 343. Okay, so this is it should be the quotient and the remainder, is 2390. That feels like a very big number though. Let's see how that works. Okay, so let me try to verify x raised to power 4 minus 1. Okay, I just want to quickly verify that. X raised to power 4 minus 1. So that's like x raised to power 4 minus, okay, plus 0x cubed plus 0x squared plus 0x minus 1. Then x minus 7 right here is x cubed. Then we have x raised to power 4 minus 7x cubed. Okay, I think it makes sense. So this cancels out. So we have 7x cubed plus 0x squared. So x goes here. We have plus 7x cubed. Okay, that's making sense. That's 7x squared rather. So 7x squared times x, that is 7x cubed. 7 times 7, that's minus 49x squared. Okay, it's making sense. So this cancels out again. We have 49x squared plus 0x. So x goes in 49x squared, that's 49x. So we'll multiply again, that's 49x squared, all right, minus 343. That's minus 343x. So we subtract, this cancels out. So we have 343x, okay, minus 1. 343x minus 1. So x goes in 343x, that's plus, okay, making sense. So plus 343, okay? So 343 multiplies that as 343x. 343 times minus 7. So that's, well, okay, I think it works. 343 times 7, to be sure now. 21, we have 2. 28. 28 plus 2. Oh, I think that's where something must have been wrong. 7 times 3. 343 times minus 7. So 7 times 3, 21. We have 2. 7 times 8, 428 plus 2, 30. So we have 3. 7 times 3, 21. So 21 plus 3, that's 24. So that's 2401. I think That's where I must have got something wrong. Yeah, this is 7 times 3, 21. We hold 2. 28, that's 30. Okay, 30. Then we hold 3. 7 times 3, 21. That's 2401. 2401 minus 1. That's 2400. 2400. Okay. So, and this is where this is 2400. 2400. There's even a way to verify that one too. So this is 2400. Okay. So here now we have minus 2401. So if we subtract, this cancels out and we just have 2400 as a remainder. Okay. So the way to verify is the remainder is simply like this. So we can verify remainder easily. So to verify remainder, I think we are still going to get there. So there's a remainder theorem which I'm going to come across, but I just want to use that ahead now. To verify the remainder, what do? We have x raised to power 4 minus 1 all over x minus 7, right? So what we are just going to do is we say let x minus 7 be equal to 0, which implies that x is equal to 7. So we now substitute 7 into that expression. So if f of x is x raised to power 4 minus 1, then we now say f of 7 is equal to 7 raised to power 4 minus 1. Okay, and that's where the deal is. 7 raised to power 4 is 49 times 49, right? So 49 times 49. Okay, 49 times 49. Okay, let me just quickly do it on my phone and drop the answer. So I think we should be in order. 49 times 49 multiplied by 49. That's 2401. Okay, we are good. 2401. So, okay, 2401 minus 1. So that's 2400. So we are correct. All right. So we are good to say that x raised to power 4 minus 1 all over x minus 7 is equal to the quotient. The quotient that is, what's the quotient again? X cubed 7x squared. So that's x cubed plus 7x squared. Is there any minus anywhere yet? X cubed 7x squared plus 49x plus 343 plus 49x plus 343. Okay. Plus the remainder, that's 2400 divided by x minus 7. Okay, so that implies that x raised to power 4 minus 1 is equal to x cubed. Okay, that'll be x minus 7 into x cubed plus 7x squared plus 49x plus 343 plus the remainder, that is 2400. I never expected it to be this big, but it's okay. At least thankfully we have a way of verifying. So that's how that goes. And I think now we see why this video had to be a separate video. So that's for the synthetic style. So with different methods, and we can always verify. So with this, it leads us to the practice question. So for each question, write the quotient and remainder. So use long division where appropriate and synthetic division when the divisor is of the form x minus c. So you can use long division for everything, don't forget. All right. But so in this case, you can use long division. Here you can use long division, but you can also use synthetic division because x minus 2, x minus 1, you can use you can use synthetic. You can use long division for everything, right? So long division, only you can use synthetic here or long division. You can use synthetic here, long division. You can only use long division here. You can use synthetic here because it's of the form x minus c. You can use synthetic here. Then if you are dividing this, you can use okay. Well, I did not try this x plus c thing. Maybe c will just be minus 2. So maybe that works. If you want to, can somebody verify that and let me know if that can work. All right. And then here too, we want to use a synthetic division to try this out because it's of the form x minus c. Then here too, here, I think long division will be better here because although I didn't do something involving 3 terms, but it's the same procedure. So what you just do is x goes in 2x in x4, that's 2x2 and then 2x2 multiply each one, then you subtract and drop 2. In this case, you have to drop 2 things at the same time and go on like that, okay? So thank you so much for listening. It's just been a long video. I never thought it would be this long, but it's okay. It's for the good. Right. So thank you so much for listening. Thank you. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. Okay. Yeah. If you have subscribed already, I thank you very much. If you haven't subscribed, why not go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of this channel by clicking on join, and it gives you some special benefits. At the highest level, we can have a one-on-one hangout physically if you're in the same location or online to talk about any of the things that interest me. The things I talk about, like maths, like data analysis, data science, scholarships, whatever interests you on this channel, we can discuss it. Okay. If you're a member of the channel, that is. Beyond that, be sure to comment, like, share, so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.